Assalamualaikum and good morning everyone. So today we are from group 3. We'll present our assignment entitled Superconductor. Our assignment will be presented by Muhammad Irfan bin Busrah, Muhammad Aiman bin Muhammad Kamal, Muhammad Amirul Firdaus bin Abdul Ghani, Muhammad Ainul Fitri bin Abdul Aziz and Najah Auni binti Norman.
A superconductor is a substance that conducts electricity without resistance, zero resistance when they are cooled to an extremely low temperature known as the critical temperature. The first person to introduce superconductor was known as Chameleonis, also the first person to liquefy helium and reach temperature as low as 1.7 Kelvin. Superconductor works by the vibration of atoms. At large distance and low temperature, lack of thermal energy allows pair of electrons to hang together. The materials of superconductor are all electrical insulators. When combined to form a composite, the composite is a superconductor that can conduct very high current over long distance without any loss of energy. Materials such as copper oxide, barium oxide, and yttrium oxide are all the materials that are known to produce a composite known as perovskite, which are used in the superconductor. So here you can see the chemical equation for making superconductors. The superconducting properties of YbCO are sensitive to the value of X, its oxygen content. Only those materials within the specific range are superconducting below critical temperatures. Meanwhile, superconductors has two types, which are type 1 and type 2. Type 1 has single critical field, whereas type 2 has two critical fields. Another phenomenon to explain superconductor are known as the Meissner effect. The Meissner effect is the expulsion of magnetic fields from superconductor when it is cooled below the critical temperature. Some uses of superconductors are including magnetic resonance imaging, MRI, generators, transformers, amplifiers, and some computer parts. High-speed levitated train also use electromagnet and superconductors as well. So here are the use of the superconductors.
Next for the problem statement. Firstly, the existence of heat causes the loss of electrical energy in form of heat. As an example, when the current flows through the wire, heat energy will lost to the surrounding. This process is called dissipation of energy, the loss of energy in the form of unwanted energy. Okay, for the number 2, magnetic field exists inside a current carrying conductor will exert a force and make the conductor move. So when the current flow inside the conductor, it will produce magnetic field, and then the force will make the conductor move inside the magnetic field, so it will produce electromagnetism. So the effect of electromagnetism is electromagnetism heat up very fast, it takes a lot of energy to use, and there is a radiation from electromagnetism. Lastly, there is a limit on how far an electric current can go through in the wire because of resistance. So as we know, from Ohm's law, current is inversely proportional to the resistance. So it means that the higher the resistance, the lower the current flow. So when the wire has higher resistance, so the less current will flow inside the wire.
Hello, Assalamualaikum. My name is Muhammad Fitri, and I'm going to present the solving problem regarding superconductor. So in the superconductor, there is no heat generated. So because of no heat generated, so there is no loss of electrical energy just by heating the wire. So by looking at the diagram, there is no resistance when superconductor reach the critical temperature. So no resistance, there is no heat generated. So that's why by using a superconductor, energy can be flowed efficiently through them without generating an unwanted heat. So no heat generated, no voltage needed, so current will flow forever. So the second one is there is no magnetic field can exist within a superconductor because the magnetization inside it is equal and opposite to the magnetic field. So it cancelling out the magnetic field everywhere within the superconductor by a phenomenon known as Meissner effect. So Meissner effect is the expulsion of the magnetic field from the interior of a material that is in the process of becoming a superconductor. There is they losing its resistance to the flow of the electrical currents when cooled below the critical temperature called the transition temperature, usually close to absolute zero. So that's why you see the magnetization become like this. This is the before the process, and this is before the process, and this is after the process. So this field cancels the applied magnetic field, so making the superconductor exhibit a perfect diamagnetism. So the third one is the superconductor. They have Cooper pairs that can stop resisting electrical current, and they allow it pass through freely. So the Cooper pairs they condense together in a coherent state. So this leads to a gap in the spectrum of allowed energy states, which they forbids electrons from having momentum uncertainty. So there is no resistance. So this happens because when the first electron, which is negative, attract to the positive ion, and then in return, the region attracts another electron, so they become the condensed together in a coherent state, which is the Cooper pairs. So the two electrons become indirectly linked to form a Cooper pairs thanks to the atomic orbit, which is the crystal lattice.
Now I'll move on to the superconductor significance and appropriateness. Firstly, superconductor is useful in making large powerful electromagnets as its wire can carry immense electrical currents with no heating, allowing it to generate large magnetic fields to be used in our technology nowadays. Next, superconductor function in long distance electricity as supercurrents formed by superconducting junction in superconductor can flow for decades. Also, the superconductor grid is able to lessen the loss of energy than our common grid. Plus, the superconductor can be buried in ground. In the wideband telecommunication, superconductor used as a receiver to easily achieve the gigahertz frequencies. Significance of superconductor is in the medical area. Superconducting magnets is used in the development of magnetic resonance imaging (MRI) as it produces large magnetic fields, which is helpful to see the inside of a patient's body without conducting surgery on them.
Moving on to history of superconductors. In 1911, a Dutch scientist named Huyck Camerlingus first discovered a superconductive material and also the first person to liquefy helium, which reached temperatures as low as 1.7 Kelvin. In the 1960s, two practical superconducting devices were developed and commercialized. One was the discovery of NPTI superconductor, and the second one was the Josephson junction. In late 1986, J. George Bernoulli and K. Alexander Muller, two researchers at IBM's Zurich lab, discovered and announced an oxide material that superconducted at 30 Kelvin. They were awarded the Nobel Prize in Physics 1987 for their work. Then, in 1987, Paul Chu at the University of Houston discovered YBCO, which became a superconductor at just 90 Kelvin, which can be reached using liquid nitrogen, a common industrial refrigerant. Over the next several months, discoveries of BSCCO and TBCCO, a type of corporate superconductor, brought the transition temperature of superconductors up to 127 Kelvin. This discovery of these high-temperature superconductors sparked vast interest and an entire industry dedicated to the research and commercial development of these materials, and their applications has emerged. In conclusion, superconductors are solids that at low temperatures exhibit zero resistance to the flow of electrical current, a phenomenon known as superconductivity. The temperature at which the electrical resistance of a substance drops to zero is its superconducting transition temperature, Tc. Superconductors also expel a magnetic field from their interior, a phenomenon known as the Meissner effect. Lastly, superconductivity can be explained by the BCS theory, which says that electrons are able to travel through a solid with no resistance because they couple to form a pairs of electrons, which is couple pairs. For now, that's all from us. Thank you.